Alright, hello and welcome everyone. Welcome back to this amazing platform of Tutee Learning. So, we are live again, and today we're going to discuss about the Bernoulli's equation, right? The Bernoulli differential equation or the Bernoulli equation in form of the linear differential equation of first order, right? So, today our agenda of discussion is to discuss about the Bernoulli equation of differential form. As well, we're also going to discuss about the orthogonal trajectory, right? So, if I have a family of curve, now we are going to discuss about the orthogonal trajectory as well, right? So, let's start our discussion on that particular topic. So, I welcome all of you to this amazing platform, and before we start, I hope you can see on the screen the questions that I gave you for homework in our last class, right? So, I hope you have solved these problems, right? So, before you are going to start with the discussion of the today's class, right? So, if you have solved this question, please let me know what is the solution you are getting so that we can discuss about the solutions. Anyone? Any answers? Roshan, hi. Any one of you have tried to solve this question? Anyone? Have you tried to solve these questions? All right. Also, I mentioned about that if you have any problems, any questions, any doubts, you can always contact me on this particular number, okay? So, please make use of all the facilities in order to study for your examination, okay? So, let's get started with this particular discussion. So, in our last class, I gave you these two homework problems to practice. So, if I talk about the solution of this, the first question is very simple, okay? So, if I try to discuss about the first problem, what you do over here is that you have to first of all try to reduce it in the simple form, that is I can write dy upon dx minus, so this will be tan 2x by secant square x, which is equals to, so if I divide by cos square x, and that is basically secant square x into tan 2x, right? So if I so this will become equals to secant square x into tan 2x whole multiplied with y, and that is equals to cos square x, right? So here my p term becomes like this one, and my q term becomes over here like this, right? So if I try to find the integrating factor for this, it is basically e to the power integration of secant square x into tan 2x, and then I have dx, right? So this can be easily integrated by taking, so tan 2x can be written as, so I hope you recall from the trigonometry that tan 2x is basically equals to 2 times of tan x divided by 1 minus, divided by 1 divided by 1 minus tan square x, right? So I hope you can follow from this discussion. So our integrating factor, so from here if you try to solve this integration, this can be solved easily by taking tan x as t, then secant square x dx becomes dt, right? So this will be easily integrated, and all right. So or else what we can do is that if I assume 1 minus tan square x as t, then 2 tan x or minus 2 tan x into secant square x becomes dt, right? So this is much simpler. So this integrating factor over here becomes integration e to the power integration of dt upon t, which is equals to e to the power natural log of t, and that is basically equal to t, right? So for the first solution, the first problem, the integrating factor, the integration factor becomes equals to 1 minus tan square x, right? So it will become 1 minus tan square x, and then we know the general solution is basically y into integrating factor is equals to integration of q of x into integrating factor into dx, right? And then I have a constant plus c. So this is my general solution, all right? So if you try to solve this problem by using this, and finally the solution that you will obtain is that, so I'm writing the final solution, right? For the first problem, the final solution or the final curve will be equals to y is equal to sine 2x, y is equal to sine 2x upon 2 times of 1 minus tan square x. Okay, 2 times of 1 minus tan square x. So this is going to be the particular solution or the equation of the curve, right? I hope this is clear to all of you. Are you all able to get this solution? Good evening. Good evening, SS. All right. So I hope this discussion is clear. And even if you try to solve this question, this will be the final answer. Okay. Is this clear to all of you? Is this clear to all of you? Please let me know in the live chat. Is this clear or not? So the final solution is like this over here, right? Similarly, I hope you have tried to solve this second problem. The second problem was much easier. So here my P is phi dash of x and Q is phi of x into phi dash of x, right? So this can be easily solved, right? And I hope you will be able to get to the final answer as, so final answer will be y into e to the power phi of x is equals to phi of x minus of 1 minus of 1, this particular part multiplied with e to the power phi of x plus some constant c. So this is going to be a general solution for the second problem. The second problem was fairly easy, right? In the first problem, the only trick was to basically get to the integration, right? I hope this was clear to all of you. I hope this was clear, right? So let's discuss about today's topic, that is, we're going to learn about the Bernoulli's equation, right? So let's discuss about the Bernoulli equation of differential equation form, right? So let's discuss about the Bernoulli equation, right? So if I talk about the Bernoulli equation, now please note that sometimes a differential equation may not be linear, that is, it is not linear by looking at its first go, but it can be converted into linear form by suitable substitution, right? So if I have a non-linear form of differential equation that can be converted into a linear form by taking suitable substitution, okay? So I can convert a non-linear equation into a linear equation by some substitution, right? So from here to here, I have to do some substitution to get to the linear form, right? Alright, and this particular form of differential equation, that substitution that we are doing, is basically defined or known by the name of Bernoulli equation, right? So if I have a differential equation of the form that is dy upon dx plus p into y is equals to q into y to the power n. So if I have this form of equation, it is not linear form of differential equation by looking at its first, right? So if p and q are function of x only, and this form of differential equation are known as the Bernoulli equation, right? Now here, if my n is equal to 0, then it will be directly equal to a linear form of equation, which we have already seen in our last class, right? However, if n is not equal to 0, then this class of differential equation is not linear, but can be converted into linear form by doing suitable substitution, right? So what if I take y to the power n common, then it will be y to the power minus n into dy upon dx plus p into y to the power 1 minus n is equals to q, right? Now from here, the interesting catch over here is that if you assume y to the power 1 minus n as some variable t, so let us say I assume y to the power 1 minus n is some variable t, then if I differentiate t, so dt upon dx is equals to 1 minus n into y to the power minus n into dy upon dx right? So I will have this particular form of the derivative, right? And therefore what I'm going to do over here is that now I'm going to replace this y to the power minus n dy upon dx with this particular form over here, and then I can replace this and I write it as dt upon dx into 1 upon 1 minus n into 1 upon 1 minus n, and then this particular part is basically t times of p is equals to q. T times of p is equals to q. Now please note that once we did this particular substitution, our differential equation will become or converted into the form of the linear differential equation, which I can also simply write it as, because n is a constant, so 1 minus n is also a constant, so I can write this expression as dt upon dx plus 1 minus n t into p is equals to 1 minus n times q. So this is the final form of the linear differential equation. So what we started from, so we had a form of nonlinear differential equation, and from there we achieved or reached the linear form of differential equation. Alright, so from there we have come to the linear form of differential equation, and this can be easily solved, what we have learned, by taking the integrating factor and by doing the suitable general solution, right? So over here my integrating factor or if I am writing over here, it is e to the power integration of 1 minus n times p dx, right? And therefore our general solution will be y into, sorry, now it is not in terms of y. Please note that we have already done a substitution, right? So our final form should be in form of t multiplied with e to the power integration of 1 minus n into p dx is equals to integration of 1 minus n times q into e to the power integration of 1 minus n times p dx, and then whole multiplied with dx, right? So this will be the final or general form of the equation in terms of the variable t, right? But you have to note that your final answer should not be in terms of t, it should be in terms of y. So we have to come back and substitute that we have assumed t as y to the power n, right? So we have assumed t as y to the power n, sorry, y to the power 1 minus n, right? So we have assumed t as y to the power 1 minus n. So please note that don't forget to do this particular substitution back, right? So this will be the final form of the general solution, right? So finally you have to substitute t with y to the power 1 minus n. So this is going to be the general solution. Alright, so this is going to be a general solution of the final differential equation, right? I hope this is clear to all of you. Is this problem clear to all of you? Please let me know in the live chat. Is this part clear? Is this form clear to all of you? Is the general solution clear to all of you? Please let me know in the live chat. If you have any query, you can always post that in the live chat so that we can discuss about that right now. Okay. And also another quick reminder, please share this video with your friends as well as your relatives or any of your juniors who are basically preparing for their JEE Mains and Advanced preparation. And they are definitely going to give their JEE Mains and Advanced this particular year. Or even if they are in class 11th, you can also share this channel with them, right? So through this channel, I am trying to promote the free education, and we are basically helping out the students, especially in class 11th and class 12, with concepts from maths, chemistry, physics, as well as biology, right? So for biology, we have our dedicated channel, that is Tutee Learning NEET. Okay, so you can always follow all those three platforms, right? So I hope this is clear to all of you. So if this is clear, let's try to solve some problems so that we can understand this particular concept in much detail, right? So let's try to solve some problems, right? So please try to solve this particular problem over here. Try to solve this differential equation which is given as y times of log x minus 1 whole multiplied with y dx over here dx, which is equals to x times of dy, which is equals to x times of dy, right? Please try to solve this problem. Please try to solve this differential equation. Try to solve this differential equation. Give it a try. Everyone, please give it a try so that we can discuss about the solution. Okay. Just give some try so that you can understand that what we are going to discuss, right? So the first and foremost thing that you need to do over here is that let me write the equation in form of dy upon dx, right? So if I write in dy upon dx, we have one x over here. So I can write it as x times dy upon dx is equals to y square into log of x minus of y. Now I can take this and simplify. So the given differential equation is dy upon dx plus y upon x is equals to y square log x upon x, right? Is equals to y square log x upon x, right? So if you look at this particular form, this is a non-linear form of differential equation, right? Now it is non-linear because of this y square term, right? So what I'm going to do over here is that now if I divide or both this side by y square, it is going to be y to the power minus 2 dy upon dx plus y upon x into y to the power minus 2 is equals to log x upon x, right? Now from here, if I assume the 1 upon y, so this will become, so y into y to the power minus 2, this will become 1 upon xy, right? Which is equals to, right? So this will be a final form of the differential equation, right? Now from here, if I assume, if I assume 1 upon y as some variable v, let us say I assume like this, then if I differentiate both this side with respect to x, so dv upon dx will become equals to 1 upon y square, okay, 1 upon y square minus 1 upon y square, and we'll have dy upon dx, right? So which can be replaced over here. So this particular form can be replaced, and finally we will have the following differential equation as dv upon dx with a minus sign, and that minus can be accumulated over here, is equals to, and a minus over here, right? So which is the standard linear differential equation, right? Now from this particular part, the solution of the differential equation is much simpler. What we have to do is that we have to finally find out. So from here, we have to get to the integrating factor, that is basically e to the power integration of minus of 1 upon x dx, and that is basically going to be equal to minus of, sorry, 1 upon x, right? That is going to be 1 upon x, right? I hope you can follow it from here. Now once we get to the integrating factor, our general solution is basically not in y. Please note, this should be not in y, okay? This should be t, sorry, we have assumed this is v, right? v into 1 upon x, that is the integrating factor, should be equals to integration of 1 upon x into log x by x, and there is a minus over here, and then we have dx, right? So I have to carry out this integration by parts. So if I just carry out this integration by parts, and finally, and by substituting v as 1 upon y, final form of the equation will be 1 upon y. So 1 upon y is equals to 1 plus log x, 1 plus log x plus some constant times x, right? So which I can combine that, I can write this as form of, so I can write y times of, now 1 plus log x will become log of e into x plus Cx, and that is equal to some 1, right? So this is going to be the final general solution of the differential equation. I hope this is clear to all of you. Is this part clear? Is this solution clear to all of you? Is this part clear to all of you? Please let me know in the live chat. Any questions? Okay. I hope this form of differential equation is clear to all of you, right? These are really interesting problems, okay, and a really interesting class of differential equation problems, right? Now, another example can be shown where I can have another class of differential equation. I hope this is part of the differential form of the solution is clear. Now, we can have one more type of differential equation where we can have another type of equation which is reducible to linear differential equation, that is, if I have f dash of y into dy upon dx plus p of x into some function of y, and that is basically equals to q of x, right? So this form of differential equation can also be converted into linear by doing a simple transformation, that is, if I assume z as f of y. So if I assume z as f of y, then the following differential equation will become equals to dz upon dx, right? So this particular part will become dz upon dx plus p of x into z is equals to q of x, right? So this will be the another linear differential equation, right? So which can be reduced to this linear form of differential equation, right? So we can also have this form of differential equation as well, right? So let's try to solve one such example. Let's try to solve one such example so that you can understand this question in a better way, right? So let us say solve for the differential equation that is given as secant square y dy upon dx plus 2 times of x into tan of y is equals to x cube, right? So please try to solve this differential equation. Very simple. Just apply the concept that I have discussed above, right? So please try to use the note that we have discussed and try to solve this by reducing it to the linear form of differential equation. And please note that when you're writing the final solution, please don't forget to get back to the final form of the differential equation, that is in terms of x and y, right? So even if you're doing a transformation by assuming some variable, don't write the answer or the general solution in that particular form. I have seen a lot of students doing these mistakes, but this is a very terrible mistake, okay? So please take care of that so that you don't make that kind of silly mistakes, okay? So please try to solve this problem. Try to solve this problem so that we can discuss about the solution. Please try to solve this problem. Please try to solve this problem. If you have any problems, please let me know in the live chat. If you have any queries, any questions, please let me know in the live chat. All right. So again, in this problem, if you look it too carefully, what you can check over here is that if you assume, now since you don't have y term directly over here, so if you assume this particular term, tan of y as some value t, then if I differentiate both the side, tan x secant square y secant square y into dy upon dx will be equals to dt upon dx, right? So if I just do this transformation over here, then the differential equation will get reduced to dt upon dx plus 2x into t is equals to x cube, right? So from here, this is basically the well-known linear form of differential equation. So where I can find the integrating factor, that is e to the power integration of 2x dx, that is basically equals to e to the power x square, right? And then the general solution in terms of t will be t into e to the power x square is equals to integration of x cube e to the power x square dx, right? Which I can easily solve by taking as so I can write x cube as x into x square. So if I assume x square as some another variable v, then in this case 2v dx becomes dv, right? So this particular form will be equals to some variable, that is v, that we are assuming. So v into e to the power v dv. Now don't forget there should be 1 upon 2 term over here and the integration of this, right? So the general solution is in this particular form. Now once you are getting the general solution in terms of t, right, now please don't forget to substitute back, that is t is equal to tan of y. Alright, so if you try to solve this problem to the final step, so the final answer in terms of the y and x is going to look like, so our general solution will look like tan of y is equals to some constant time e to the power minus x square plus 1 upon x square minus of 1. So this is going to be the final general solution of the following differential equation, or the family of curve which satisfy the above differential equation. I hope this solution is clear to all of you. Is this solution clear? Please let me know in the live chat. Is this solution clear to all of you? Is the solution clear? Is the following solution clear? Okay. So I hope this solution is clear because it's a very simple problem. If this solution is clear, please try to solve the next problem, right? The next problem is going to be really interesting. So this particular problem is again an interesting problem. Alright, so this equation is given as dy upon dx plus x into x plus y, x into x plus y is equals to x cube into x plus y whole cube minus of 1, right? So I have this as the following differential equation. Now by looking at it, it is very non-linear, right? So try to solve this problem. Try to solve this problem. So try to solve this problem. This is a very interesting problem. Okay. Hi. Hi, Srey. Which part should I repeat? Tell me. Which part of the solution is not clear? Which part is not clear? Srey, if you have any questions, okay, Srey, you can always contact me on that particular number that is given on the live chat. Okay, you can check the live chat. There is a number that you can see over here. Alright, so please contact me on the number so that we can discuss about the doubt. Okay, otherwise we shall proceed with the class. Okay. Previous question. Okay, so see, Srey, over here in the previous question, if I look at this particular differential equation, it is not directly a linear differential equation, right? In order to make this a linear differential equation, I must have not a function. I must have only y over here, right? But over here, I have a function of y, right? So what I did is that I assumed this particular thing as some variable v or t, okay, so that this particular part becomes simply with that particular differential equation. Alright, and if I do that particular transformation, as I can see over here, then this particular form will become to a linear differential form that you can see over here. Okay, now this is a linear differential form. Hi आशीष आशीष डाउट डिफरेंशिएशन समझ में नहीं आया इस क्वेश्चन का. कौन सा डिफरेंशिएशन समझ में नहीं आया आशीष? Which part? Can you tell me? देखो आशीष, over here what I did is that I assume tan y as some variable t, right? So if I differentiate both this side, so here over here I have to apply the chain rule, right? I am differentiating with respect to x, right? So differentiation of tan y becomes secant square y, and then I have to differentiate y as well. So differentiation of y will become dy upon dx, which is equals to dt upon dx. Is this clear, आशीष? समझ में आया आशीष? Sir, if you tell in Hindi, I will understand more clearly. ओके ठीक है, मैं हिंदी में बोलने की कोशिश करूंगा, ठीक है. देखो, अगर तुम बेसिकली इस क्वेश्चन को ऑब्जर्व करते हो ना ढंग से, क्या मिलेगा यहाँ पे, मैं क्या बोलने की कोशिश कर रहा हूँ कि हम अगर लीनियर डिफरेंशियल इक्वेशन सॉल्व करते हैं ना, तो जो लीनियर डिफरेंशियल इक्वेशन किस फॉर्म का दिखता है. अगर मैं लीनियर डिफरेंशियल इक्वेशन को मैं लिखने की कोशिश करूँ, तो जनरली ये लीनियर डिफरेंशियल इक्वेशन का फॉर्म क्या होता है कि आई हैव dy अपॉन dx प्लस p ऑफ x इनटू y एंड दैट इज इक्वल टू सम फंक्शन ऑफ x, राइट. ये होता है एक सिंपल लीनियर डिफरेंशियल इक्वेशन का फॉर्म, राइट. पर अगर तुम इस क्वेश्चन में देखोगे, यहाँ पे y के जगह मेरे पास एक फंक्शन ऑफ y है. So I don't have a y directly. For a linear differential equation, I should have y over here multiplied with some function of x, right? But यहाँ पे क्या हो रहा है कि I am not having y directly, whereas I am having tan of y, which is a function of y, right? So in respect to this question, it is basically given something like some function of x into some function of y, and then instead of dy upon dx, I have the derivative of that function of y with multiplied with dy upon dx, right? So this is the form. तो अगर मुझे इस फॉर्म ऑफ डिफरेंशियल इक्वेशन दिखाई देता है, तो व्हाट आई एम गोइंग टू डू ओवर हियर इज दैट आई एम गोइंग टू एज्यूम दिस f of y as some variable t. So I am going to assume over here as f of y as some variable t. Now in this case, if I assume this, then my dy upon dx multiplied with f dash of y will be equals to dt upon dx, will be equals to dt upon dx, right? So अगर मैं इस पर्टिकुलर ट्रांसफॉर्मेशन को करता हूँ, तो मेरा सिंपल ये वाला जो फॉर्म है ये सिंपली बन जाता है dt अपॉन dx, और ये जो फॉर्म ऑफ नॉन लीनियर फॉर्म ऑफ डिफरेंशियल इक्वेशन है ये सिंपली एक लीनियर फॉर्म में कन्वर्ट हो जाता है, राइट. तो मैंने इसी का ही कोशिश किया है करने के लिए, ठीक है. सो जस्ट बाय डूइंग अ सिंपल ट्रांसफॉर्मेशन ओवर हियर, ये पर्टिकुलर फॉर्म एक लीनियर डिफरेंशियल इक्वेशन फॉर्म में बन जाता है. क्या ये समझ में आया श्रेय, आशीष, श्रेय? इज दिस क्लियर? Is this part clear? Please let me know in the live chat, yes or no. Okay, so I hope this part is clear to all of you. तो अगर ये समझ में आ जाता है, please try to solve this problem. Okay, please try to solve question number 3. Please try to solve question number 3. I am good at physics, but I can't solve math. I try so hard, still get almost negligible results. I am a dropper. What should I do? Due to bad teacher at my academy, I didn't study maths in class 11. User 3627. See, the simple step is that कि तुम्हें अभी क्या करना है कि प्लीज ट्राई टू बी डिसिप्लिन इनफ, ठीक है. सिंस यू आर ड्रॉपर, व्हाट आई वुड सजेस्ट इज दैट डोंट गो हियर एंड देयर स्टडी फ्रॉम एनी रैंडम पर्टिकुलर प्लेटफॉर्म, स्टिक टू एनी वन पर्टिकुलर प्लेटफॉर्म. ओके, so what I would suggest is that you can contact me on the number, okay, user 3627. Please contact me on this number, okay, please contact me on this particular number. Okay, I can provide you much detailed solution or much detailed guidance. Okay, is this clear? So please contact me on this number. I can guide you in a much better way, okay? What you have to do and what not you have to do, right? And please try to stay to one particular platform and try to follow that particular content, okay? And always focus on the high priority chapter, right? Great, श्रेय. श्रेय, अगर आगे वाला समझ में आ गया तो प्लीज एक बार ये क्वेश्चन को ट्राई करो सॉल्व करने का, ठीक है? और एक मैं क्वेश्चन देने वाला हूँ यहाँ पे, okay? So the second problem, yes, you can always contact me anytime, okay? Shrey, user 3627, you can contact anytime, right? You can WhatsApp me on this particular number as well, okay? And what I would suggest is that please go for the one-to-one online batches, okay? Where you can study only with me and there will be no other students as well. So you can always opt for that one-to-one online classes, okay? So the classes will be definitely be happening using the Google Meet, and we can also have that classes so that we can have specialized doubt clearance, personalized discussion and everything, right? So it's not a promotion, it's basically for your help only, right? All right. So, and another problem, please try to solve this problem as well. That is sin y dy upon dx is equals to cos of y into 1 minus x times of cos of y, okay? Please try to solve this problem as well, okay? Please try to solve these two problems. श्रेय, अगर ये आगे वाला प्रॉब्लम समझ में आ जाता है तो ये दोनों क्वेश्चन करो. Most welcome. Okay, please try to solve these two problems as a homework problem so that we can discuss about the solution in our upcoming class. Okay, so in the next class we're going to start with the topic of orthogonal trajectory, and then we're going to discuss about the exact differential equation. Okay, so with this we're going to start with the orthogonal trajectory and exact differential equation, and then at the end we are going to move to the application types of differential equations problems, right? So please take a screenshot of these two problems so that you can practice this problem as a homework, okay? So please take this problem, please note down these two problems and try to tell me the solution in the next class. Also, if you have tried to solve this problem in today's class, you can always let the solution in the comments, okay? So with this, I would conclude the session over here. I hope the Bernoulli form of linear differential equation is clear to all of you. So with this, we are done almost with discussion about the linear form of differential equation. So our next task is to understand our orthogonal trajectory and the exact differential equation. Alright, and with this we are almost done with the chapter of differential equation, and then I will take one more class where I am going to discuss about the previous year JEE Mains and Advanced problems, right? So with this we are done with discussion about the differential equation, and our next ongoing topic is going to be vectors and 3D geometry. Alright, so I hope this is clear to all of you. And if you are new to this particular platform, I would request all of you to please subscribe to the channel and hit the like button and also hit the bell icon so that you don't miss out any upcoming notification. And also share these videos among your friends, your juniors, your relatives, so that they can also get access to this live free lectures. Alright, so with this, thank you for watching the session.